Hello friends, now I will start the first chapter, sets and relation. I will explain all the basic concept before the exercise 1.1 and all the solved examples before exercise 1.1. Now this is the introductory video. This is the first video of the chapter number 1. And in the next video, I will explain the exercise 1.1, and so that before the exercise 1.1, these are the important basic concept and the solved examples. मराठी मीडियमच्या विद्यार्थ्यांना देखील हा 1.1 एक्सरसाइजच्या आधीचा माझा हा इंट्रोडक्टरी व्हिडिओ आहे. मी अतिशय सोप्या भाषेत एक्सप्लेन करण्याचा प्रयत्न कराल. नाउ इन दिस चॅप्टर व्हॉट यू आर लर्निंग: representation of set, intervals, types of sets, operations on the sets, order, pair and the relations. Let's recall. The concept of a set was developed by German mathematician George Cantor. You have already learned about the sets and some basic operation involving them in earlier standard. तुम्ही 9th standard मध्ये काही लर्न केलेले आहे. In everyday life, we generally talk about group, a collection of objects. Surely you must have used the word such as team, bouquet, bunch, flock, family of, collection of different objects. Okay. It is very important to determine whether a given object belongs to a given collection or not. Now consider the following collections. Consider the following collections: successful person in your city, happy people in your town, clever student in your class, days in a week, first 5 natural numbers. Okay. First 3 collections are not examples of the set, but last 2 collections represents set. Okay. First 3 means what? Successful person in your city, happy people in your town and the clever student in your class. This is because in the first 3 collections we are not sure of the objects. The term successful person, happy people, clever students are all relative terms. They depends on the person to person. Here the objects are not well defined. In the last 2 collections, we can determine the objects clearly. Okay. Thus we can say that objects are well defined. What about the last 2? That is the days in week. They are definite. First 5 natural numbers 1, 2, 3, 4, 5, and we know the days in week. Okay. And therefore we say that the objects are well defined. Now the definition of set. A collection of well defined objects is called a set. Object in a set is called its element or member. We denote the sets by capital letters A, B, C, etc. The elements of a sets are represented by the small letters A, B, C, X, Y, Z, etc. If small x is an element of a set, capital A, we write X belongs to A and read as X belongs to A. If X is not an element of a set A, then we write X does not belongs to A and read as X does not belongs to A. Okay. For example, 0 is a whole number but not a natural number. Okay. And therefore 0 belongs to W but 0 does not belongs to N. Okay. Now the next, representation of a set. Okay. It's written as in the roster method. In the roster method, we list all the elements of the set within the brackets and separate the elements by the commas. Example, state the sets using the roster method. The first is B is the set of all days in a week. Okay, then we write the all the days. Okay, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and the Sunday. What is next? C is the set of all vowels in English alphabets. A, E, I, O, U. Okay. Now the next method, which is the set builder method. In the set builder method, we describe the elements of the set by specifying the property which determines the element of the set uniquely. Okay, we write the property particularly and therefore we get the unique element. For that, the example is that the state the set using set builder method. Okay, the first is y is the set of all months of a year. Therefore, y is equals to, in curly bracket, x is such that x is the month of year. Okay, then we will write here the element will be such that it is a month of a year. Okay, now the next, b is the set of all perfect squares of natural numbers. Therefore, here b is equals to, in curly bracket, x belongs to n and x is must be the perfect square. Then what are the elements here? The first will be, I will write here the first element 1, next 4 and 9, and in this way. Okay, that element must be the perfect square. Okay, next, the representation of the set by the Venn diagram. The pictorial representation of a set is called the Venn diagram. Generally, the geometrical closed figures like circle, triangle or rectangle are used to represent the sets, which are known as Venn diagrams and are named after the English logician John Venn. This you have learned in the 9th standard. Okay. In Venn diagram, the elements of the sets are shown as a point enclosed in the diagram representing set. A is equals to, in curly bracket, 1, 2, 3. B is equals to, this is the Venn diagram, it's shown like this OL step. B is equals to A, B, C, D, E, F. Okay, it is represented in the square. And C is a set 4, 5, 6. It is represented in triangle. Okay, now the next. Note that, but the important thing is that, what is you have to note, if the elements are repeated, write them once. जर repeat होते तर ते एकदाच लिहायचे. While listing the elements of a set, the order in which the elements are listed is immaterial. Okay, त्याचे order काही important नसते. कुठले order तुम्ही घेतली तरी चालेल. By listing the elements of a set, the order in which the elements listed is immaterial. Okay, now let's learn. What is next? Intervals. Open intervals. Now see this. A comma B belongs to set of real number and A is less than B. Then the set, in curly bracket, x is such that x belongs to set of real number and x lies between A and B is called open interval, and it is denoted by this type of the open interval bracket. All the numbers between A and B belongs to the open interval, but A and B themselves do not belong to these intervals. Okay, now suppose that if I had the set 4 and comma 10, means what? If I write it's like this, what is that? X is such that, okay, x is such that x belongs to set of natural number. Okay, x belongs to set of, here the natural number. Okay, and this lies between 4 and 10. Okay, is lies between 4 and 10. Okay, it means that what are the element? 5, 6, 7, 8 and 9. Okay, in this way. Therefore, this type of set is called the open set. Okay, and it is represented on the number line is like this. This circle, and that circle is not filled with anything. Okay, it is completely empty circle. Okay, this is the circle like this and this is the circle like this. All the elements are between A and B. They are not equals to A, not equals to B, but between A and B. Okay, therefore the open interval AB is equals to x is such that x belongs to set of real number and x lies between A and B. Okay, now the next, closed interval. Now see this here. This bracket, it's a open and this is a totally fill up with the dark shading. Okay, it is like this. Okay, total is like this. And this type of the interval is called the closed interval. Now see this. Let a comma b belongs to set of real number. A is less than b. Then the set x is such that x belongs to set of real number and x lies between a and b, and x is equals to a also and x is equals to b also. Means here a and b are also included here. Now again I will write here the one more set. It is that x is such that x belongs to set of natural number and the value of that x lies between 4 and 10. In this case, what are the elements? The elements are 4, 5, 6, 7, 8, 9 and 10. Here 4 and 10 are included here. And in the previous case, the 4 and 10 was not included there. And this is called the closed interval. It means that a and b are also we consider here, and it is denoted the closed bracket. Okay, and therefore closed interval ab is equals to x is such that x belongs to set of real number, x lies between a and b, and x is equals to a also and x is equals to b also, like this. Now the next semi-closed interval. Take to the left hand side, it is a semi-closed, means once for the left hand side it is a closed and right hand side it is open. Means what? X belongs to set of real number. Here a is included but b is not included. For example, again I will write one more example, similar example, that x is such that x belongs to set of natural number. Okay, again this is the natural number and these elements are 4 is less than or equals to x and is less than 10. Then what are the elements? 4, 5, 6, 7, 8 and the 9. Here we are considering the 4 and the last element is a 9. But here we are not considering the 10. And here we are considering the 4 due to x is less than or equals to. Okay. And that's why here we consider 4 is included here. Similar here a is included. Therefore, it is a semi-closed. Now semi-open. Now see this here. Here the open. Semi-open and on this side it is a closed. Now again we can write the set in curly bracket. I will write x. C is such that x belongs to set of natural number and the value of that x lies between 4 and 10 and equals to 10 also. Then what are the elements? 5, 6, 7, 8, 9 and here we take the 10 because it is a less than or equals to. Okay. Here we include the element 10 and similarly here we include the b but a we do not include. Okay. Now the sets of all real number greater than a. Greater than a, it is written as a, that is the open interval a and infinity. Here x is such that x belongs to set of real number. These all the elements are greater than a, means x is a greater than a, and hence if you take the number line, all the elements are such that they are greater than a. Therefore, all the elements from to the right hand side of this a are the elements of these sets. Means what? They start from a and ends to the infinity. Okay. Now the next, the set of all real numbers greater than or equal to a. Greater than or equal to a. See this here. All the elements was greater than a. A is not included here. And now here, the set of all elements greater than or equals to a means x is such that x belongs to set of real number and x is greater than or equals to a. And here we are including a and all the elements are greater than a. Therefore, from the right hand side of the we are taking the all the numbers, okay, including a. Now the next, the set of all real numbers less than b. Less than b means what? To the left hand side of the b means what? Minus infinity to b. We are not including the b here because it is open. Okay. Now and it is written as x is such that x belongs to set of real number and this x is less than b. Okay. Now the next, the set of all real numbers less than or equals to B means what? They are from all these elements are less than or equal to B means what? We are including the B and all the elements which are less than B. Okay, these are the representation of the sets. Okay, and we have written like this. The set of all real numbers. Set of all real numbers are from minus infinity to plus infinity, and it's a representation like this. Minus infinity to plus infinity. X is such that X belongs to set of real number and X lies between minus infinity to plus infinity. Okay. These are the representation of the sets. Okay. Now the next. Number of elements of a set. That is called the cardinality. Means म्हणजे काय की एखाद्या सेट मध्ये किती एलिमेंट्स आहेत. ओके, हे देखील तुम्ही लर्न केलेलं आहे 9th स्टँडर्डला. द नंबर ऑफ डिस्टिंक्ट एलिमेंट कंटेंट in a finite set, A is denoted by n of A. Thus, if A is equals to, in curly bracket, 1, 2, 3, 4, then n of A is equals to 4. That is the number of the elements are 4. Types of the sets. Okay. Next, empty set. A set containing no element is called an empty set or a null set and is denoted by the symbol phi or the empty curly bracket. Okay, it is like this, or a void set. For example, A is such that X belongs to set of natural number. And what type of this X? X is natural and it lies between 1 and 2. म्हणजे 1 and 2 मध्ये राहणारा कुठला नॅचरल नंबर आहे का? तर देर इज नो नॅचरल नंबर. 1 नंतर डायरेक्ट 2 हा नॅचरल नंबर येतो. देर इज नो एलिमेंट्स and hence we write n of A is equals to 0. No element. Therefore, it is an empty set. Okay, it is a empty set and the number of the elements in the empty set is a 0. Therefore, n of A is equals to 0. नेक्स्ट सिंगलटन सेट म्हणजे असे सेट की ज्यामध्ये फक्त एकच एलिमेंट असतो. अ सेट कंटेनिंग ओनली वन एलिमेंट इज कॉल्ड अ सिंगलटन सेट. फॉर एक्झाम्पल, लेट कॅपिटल A be the set of all integers which are neither positive nor negative. Okay, then the what type of the elements? Integer. ते कसे आहेत? ते नेगेटिव्ह पण नाही आहेत आणि पॉझिटिव्ह पण नाही आहेत. Then which is the element? That is a 0 is the element. If I write the set of integers, okay, if I like write it as a I and then the elements are 0, 1, 2, 3 up to infinity, and on this side -1, -2 up to the infinity. The elements are neither negative nor positive. Then which is the element? 0 is the element. Therefore, n of A is equals to 0. It is a single element and the number of the element n of A is equals to 1. And this is the answer. Next, finite set. A set in which the process of counting of elements comes to an end is called a finite set. आपण एखाद्या सेट मध्ये एलिमेंट्स काउंट करायला सुरुवात केली आणि शेवट झाला त्याचा, then it is called the finite set. For example, the set of letters in the word beautiful. Okay, then we write A is equals to in curly bracket B E A U T I F U L. Therefore, n of A is equals to 8. Therefore, this is the finite set. A is a finite set. What about the infinite set? A set which is not finite is called an infinite set. For example, set of natural numbers. We can't count it. It is a infinity up to them. Now the next. Note that what is important? An empty set is a finite set. And Z, the set of all the points on a circle are the infinite set. Okay, Z is a set of the integers. Here I denote the set of integers like this I, but it is a Z. Okay. Now the next. Some definitions. Equality of the sets. When we say that the two sets are equal, two sets are said to be equal if they contain same elements. तेच elements असले पाहिजेत. That is, if A is a subset of B and B is also a subset of A, then we say that A is equals to B. These two sets are equal. Okay. These two sets are the equal. Okay. Next, for example, Let X be the set of letters in the word A, B, B, A, and Y be the set of letters in the word B, A, and the B, A. Okay. Now X is equals to A, B, and Y is equals to also B, A. Thus the set X and Y are equal sets, and we denote it by X is equals to Y. Now what about the equivalent set? This is important. Equivalent is important. The two finite sets A and B are said to be equivalent if n of A is equals to n of B. A and B, these are the two different sets. But if their cardinal numbers are same, त्यामध्ये असणारी एलिमेंटची संख्या जर सारखी असेल, then we say that the given two sets are the equivalent set. Here n of A is equals to n of B, and therefore A and B are equivalent sets. Okay. Now the next subset. A set A is a said to be a subset of set B if every element of A is also an element of B, and we write A is a subset of B. Okay. Next, superset. If A is a subset of B, then B is called the superset of A. म्हणजे तो मोठा. And we write B is a superset of A. Next, the proper set. A non-empty set A is a said to be proper subset of the set B if all the elements of A are in the set B and at least one element of B is not in A. म्हणजे काय की B तले सर्व एलिमेंट्स या A मध्ये नको पाहिजे, कमीत कमी एक तरी असला एलिमेंट B मध्ये पाहिजे की तो A पेक्षा जास्त आहे B मध्ये. Okay. If A is a subset of B and A is not equals to B, then A is called the proper subset of B, and it is denoted like this: A is a proper subset of B. Here let A is equals to in curly bracket 1, 3, 5 and B is equals to in curly bracket 1, 3, 5, 7. Now here all the elements of A are in B, but there is one more extra element which is the 7, and it is not in the set A. Then every element of A is an element of B, but A is not equals to B, and then A is a subset. A is a proper subset of B. That is A is a proper subset of B. Now the next remark: if there exists even a single element in A which is not in B, then A is not a subset of B, and we write it is like this. Okay, A is not subset of B. Okay. Now the next, universal set. This is also very important in a particular discussion. Means what? If we are considering all the books in our library, okay, all the books of 9th standard, all the books of the 11th standard. This is the particular discussion. If in a particular discussion all the sets under the consideration are subset of a set, say U, then U is called the universal set for that discussion. The set of natural number, the set of integer are subset of the set of real number. Set of natural number and set of integers हे कोणाचे सबसेट आहे? the set of real number चे. हा आपला पर्टिक्युलर डिस्कशन कोणा बाबतीत आहे? तर नंबर्सच्या बाबतीत आहे, सेट्सच्या बाबतीत आहे. Thus, for this discussion, R is a universal set. In general, universal set is denoted by capital U or the capital X. Okay. Now the next, power set. The set of all subsets of a given set A is called the power set of A and is denoted by P of A. Thus, every element of power set A is a set. For example, consider the set A in curly bracket AB. Let us write all the subset of the set A. We know that the phi is a subset of every set, म्हणजे प्रत्येक सेट मध्ये हा phi असणारच आहे. So phi is a subset of A. Okay. Also, what are the subset of this AB? First is A, B, AB. I will repeat again. Also A, B, AB are also subsets of A. Thus, the set A has in all 4 subsets, namely phi, A, B, AB. Therefore, the power set P of A is equals to phi, A, B, AB, like this. Then how many elements are there? There are the 4 elements. Okay. Now the operations on sets. First is complement of a set. Let A be subset of universal set. The complement of the set A is denoted by A dash or A raised to this small c. It is defined as complement म्हणजे काय? That A complement is equals to X is such that X belongs to that particular discussion U, particular universal set U, and X does not belongs to A. The set of all elements in U which are not in A is called the complement of A. म्हणजे A मध्ये suppose that U is equals to 1 to 10 आणि A मध्ये 1 to 5 असेल तर A complement म्हणजे काय? तर 6, 7, 8, 9, 10 like this. 6, 7, 8, 9, 10 they are not in A but they are in U. Okay. Now the next example. Here let X is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is set. Be the universal set and A is equals to 2, 4, 6, 8. See this here, the figure. A, 2, 4, 6, 8. And A is equals to what is that? 0, 1, 2, 3, 4, 5, 6, 7, 8. Then what about the A complement? म्हणजे उरलेले सर्व elements. That is a 0, 1, 3, 5 and 7. This is the A complement. Okay. Now the next. The complement of the set A is A complement 0, 1, 3, 5, 7. Now the property. Complement of a complement is the original set. Complement of phi is U. U is the universal set. Complement of U is a phi. If A is a subset of B, then complement of B is also subset of complement of A. Okay. Now the next. Union of sets. Union of sets A and B is the set of all elements which are in A or in B. Okay. Thus, A union B is equals to X is such that X belongs to A or X belongs to B or X belongs to both of them. Okay. That is called the union of the set A union B means what? X is such that X belongs to A or X belongs to B. The union of two sets A and B can be represented by the Venn diagram. Okay. A union B is equals to, it is like this or it is like this. If both of them do not have the common element, then we can write it like this. If they have the common element, then we can write A union B. Okay. Now the next. The properties of union. A union B is equals to B union A. It is called the commutativity. A union B, union C is equals to A union in bracket B union C. This is called the associative property. A union phi is phi. It is the identity of union. A union A is equals to A. It is called the idempotent law. A union A complement means what? The universal set. If A is a subset of B, then A means what? A is a smaller one. Then A union B is nothing but the B. Next, U union A, that is equals to U. जे मोठा असेल तोच तिथे असणार आहे. Next, A is a subset of A union B. Then B is also subset of A union B. Okay. Now some examples. Let A is equals to in curly bracket. Now the example. Let A is equals to in curly bracket. X is such that X is a prime number less than 10. B is equals to in curly bracket X is such that X is a factor of 8. Then find A union B. Now we'll see the prime numbers less than 10. What are the prime numbers less than 10? 2, 3, 5, 7. Okay. Next, X is a factor of 8. The factors of 8 are 1, 2, 4 and 8. Okay. Therefore, what is the A union B? A union B is equals to 1, 2, 3, 4, 5, 7, 8 and this is the A union B. Okay. Now the next. Intersection of sets. The intersection of two sets A and B is the set of all elements which are both in A and B, and it is denoted by A intersection B. Thus, A intersection B is the set of all the elements such that they belongs to A as well as in B. Therefore, X is such that X belongs to A and X belongs to B, and this is the A intersection B. That is a common element of A and B. Okay. Now the next. The shaded portion in figure represent the intersection of A and B, and that is A intersection B. Now the properties. A intersection B is equals to B intersection A. It is called the commutativity. A intersection B, then its intersection with C is equals to A intersection in bracket B intersection C. Associativity. Phi intersection A, that is equals to phi. A intersection with A, that is equals to A, that is called the idempotent law. A intersection A complement, and that's equals to phi. If A is a subset of B, then A intersection B is equals to A, because A is a smaller one and their common elements is nothing but the A. Next, U intersection A is A. Next, in bracket A intersection B is a subset of A. A intersection B is also subset of B. Okay, now the important remark. If A and B, their intersection is phi, then A and B are the adjoint set. Now the distributive property, see this here. A intersection in bracket B union C is equals to A intersection B union A intersection C. Next, A union in bracket B intersection C is equals to A union B intersection A union C. Okay, now the De Morgan's law. If A and B are the subset of a universal set, then A union B complement is equals to A complement intersection B complement. Next, A intersection B complement is equals to A complement union B complement. These are the De Morgan's law. Okay. Now the example, if A is equals to in curly bracket 1, 3, 5, 7, 9 and B is equals to in curly bracket 1, 2, 3, 4, 5, 6, 7, 8. Then find A intersection B, means they are common elements. What are the common element? 1, 3, 5, 7. And hence A intersection B is equals to 1, 3, 5, 7. Now the second example. If A is equals to in curly bracket X is such that X is a factor of 12 and B is equals to in curly bracket X is such that X is a factor of 18. Find A intersection B. Now the factors of 12 are 1, 2, 3, 4, 6, 12. Okay. And factors of B are, factors of 18 are. Factors of 18 means the numbers which divides the 18. They are the 1, 2, 3, 6, 9, 18. Now their intersection means their common element 1, 2, 3 and 6. Okay. Next example. If A is equals to in curly bracket 1, 3, 5, 7, 9. B is equals to in curly bracket 2, 4, 6, 8, 10. Then find A intersection B. Is there any common element? No. And therefore A intersection B is an empty set or it's equals to 5. Okay. Now the next. Difference of sets. This is also important concept. Difference of set A and the set B is the set of elements which are in A but not in B and is denoted by A minus B. The shaded portion in figure represent A minus B. This represent the A minus B. Okay. The shaded portion A minus B. Okay. A minus B is defined as X is such that X belongs to A but X does not belongs to B. म्हणजे कॉमन एलिमेंट मधला इथला पार्ट नाही घेतला. हा इथे A मध्ये आहे पण तो B मध्ये पण आहे. म्हणून ते कॉमन एलिमेंट नाही घ्यायचे. दॅट इज नथिंग बट दी A minus B. Okay. Now the next. Similarly B minus A. Y such that Y belongs to B and that Y does not belongs to A. Let's note that A minus B is a subset of A and B minus A is a subset of B. Okay. Some similar here. This set I will denote it like this. If I take this in, then this is the B minus A. This B minus A is a subset of B. Okay, this is the B minus A. Okay, now the next, the set A minus B, A intersection B, B minus A are mutually disjoint. Okay, see this here, A minus B, B minus A, and what about here? Their intersection, A intersection B. These are the mutually disjoint. They are the separate. Okay, uh, that is the intersection of any of these two sets is the null set. That is a empty set. Next, this is also very important. A minus B is equals to A intersection B complement, and B minus A is equals to A complement intersection B. Okay. Now the next, A union B is equals to A minus B union A intersection B union B minus A. Okay. The shaded portion in the figure represent the A union B. Okay. See this here. A minus B. Next with union A intersection B. Next B minus A. It's a union B. Now the properties of cardinality of the set. N of A union B is equals to N of A plus N of B minus N of A intersection B. When A and B are disjoint sets, N of A union B is equals to N of A plus N of B, and their intersection is a phi. Okay. Therefore, N of A intersection B is equals to 0. N of A intersection B complement plus N of A intersection B, that's equals to N of A. N of A complement intersection B plus N of A union B, A intersection B is equals to N of B. You can see this, all the types of the formulas. N of A intersection B complement plus N of A intersection B plus N of A complement intersection B, and that's nothing but the N of A union B. Thus, for the next is also important, for these are the three sets. N of A union B union C is equals to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C, like this. Okay. Now the solved examples. The first example, if A is equals to in curly bracket X is such that X is a factor of 6. B is equals to in curly bracket X is such that X is a factor of 8. Then find A minus B and B minus A. First, factors of 6 are the elements which divides the 6. What are that? 1, 2, 3, 6. Factors of 8. That is a 1, 2, 4, 8. What about the A minus B? मग त्यातले कॉमन इलेमेंट दोघांमध्ये कोणते 1 2 आहे. ओके, यातनं 1 2 जर गेला तर काय राहणार 3 and 6. Therefore A minus B is equals to 3 6. B minus A, B 1 2 4 8, and what is here 1 2. Then what are the remaining 4 and 8? 4 and 8, these are the remaining. Okay. Now the next example number 2. A is equals to in curly bracket 1 upon X. Okay, 1 upon X is such that X belongs to, there is a X belongs to set of natural number and X is less than 8. And B is equals to in curly bracket 1 upon 2X is such that X belongs to set of natural number and X is less than or equal to 8. Then find A minus B and B minus A. Okay, this is first A. Then what are the element? X, 1 upon X is such that it belongs to set of natural number and X is less than 8. The first element is 1, second is 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7. We are not taking 8 because X is less than 8. Now the B set 1 upon 2X. X is belongs to set of natural number and X is less than or equals to 8. Okay. The elements are, if you take 1, then 1 into 2, 2 into 2, then 2 into 3, 2 into 4, 2 into 5, 2 into 6, 2 into 7 and 2 into 8. We are taking here 8. Therefore, all these are the elements. A set मिळाला. Next, this is the B. What about the A minus B? मग या दोघांमध्ये कॉमन कोणते आहे? 1 by 2. Next is a 1 by 4, 1 by 6. These are the 1 by 2, 1 by 4, 1 by 6. हे सोडून उरलेले सगळे. 1, 1 by 3, 1 by 5, 1 by 7. What about the B minus A? Then the common elements, that is the first is 1 upon 2 will be not there, 1 by 4 is not there, 1 by 6 is not there, and all the remaining elements are here. Okay. Next, if A is equals to 1, 2, 3, 4 and B is equals to 3, 4, 6, 7, C is equals to 5, 6, 7, 8, D is equals to 7, 8, 9, 10, then find A union B. Next, A union B union C. Next, B union C union D. Okay. Are the sets A, B, C, D are the equivalent? Now the solution. First union, we can find out their union, which is A union B is a 1, 2, 3, 4, 5, 6. Okay. यामध्ये A union B आपण इथे केलेलं आहे. त्यातले common element 3 and 4 and we are taking one time that. A union B union C. That is A union B union C. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Next, B union C union D. B union C union D. Then you will get 3, 4, 5, 6, 7, 8, 9, 10. This is the B union C union D. As the number of the element in every set A, B, C, D is a 4. See this here. Here is a 4, 4, 4, 4. Okay. And therefore, the sets A, B, C, D are the equivalent set. Okay. If the number of elements in a sets are same, then they are called the equivalent sets. Now the example number 4. Let U is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Be the universal set. And A is equals to 1, 3, 5, 7, 9. B is equals to 2, 3, 4, 6, 8, 10. C is equals to in curly bracket 6, 7, 8, 9. Okay. Then find A complement. म्हणजे काय? A मध्ये we are finding the elements A मध्ये नसलेले पण ते U मध्ये असणारे. Okay. Now this is a U. A is this 1, 3, 5, 7, 9. U मध्ये मधले आपण असे एलिमेंट्स घ्यायचे की जे A मध्ये नको असले पाहिजे. That is other than A which are in U, which are the 2, 4, 6, 8, 10. Okay. A intersection B complement. First of all, we will find out the A intersection C बघणार. What is A intersection C? It is A हा झाला C झाला. दोघातला intersection 7 and 9 and their complement. म्हणजे 7 and 9 सोडून सगळे U मधले एलिमेंट्स. ओके. 7 and 9 सोडून सगळे U मधले एलिमेंट्स 1, 2, 3, 4, 5, 6, 8 and 10. 7 and 9 आहे का? No. Okay. And if we take the union of this, you will get the U. Okay. Complement of complement is the original number. Okay. U is equals to A set घेतला 1, 3, 5, 7, 9. If I take their complement and complement of complement is the original set, which is the 1, 3, 5, 7, 9. Okay. याचा कॉम्प्लिमेंट घेतला म्हणजेच काय ना 2, 4, 6, 8, 10 व्यतिरिक्त एलिमेंट्स. मग ते घेणार ते कोणते येणार 1, 3, 5, 7, 9. That is nothing but the A. And hence complement of complement is the original set. Next B minus C and it's a complement. तर U घेतला आपण. And what is a B? This is a set B. Minus B minus C. म्हणजे B आणि C मधले कॉमन एलिमेंट जे असतील ते B मधनं कट करायचे. That will be the elements of the B minus C. Which are the common element between B and C? The common elements are 6 and 8. Okay. मग 6 आणि 8 आपण इथनं कट करणार. Common element. This is 6, 8. 6 and 8. 7 घ्यायचं का नाही? 9 घ्यायचं का नाही? आता 6 आणि 8 याच्यातले कट करणार. Then you will get B minus C. Then what are the elements? 2, 3, 4 and 10. 2, 3, 4 and 10. This is the B minus C. मग याचा कॉम्प्लिमेंट. मग 1, 2, 3, 4, 10 व्यतिरिक्त एलिमेंट्स घेणार की जे U मध्ये आहेत. ओके. And they are 1, 5, 6, 7, 8, 9. Okay. These are the B minus C complement. Okay. Now the next example number 5. Let X be the universal set for the non-empty sets A and B. Then verify the De Morgan's law. What is that De Morgan's law? A union B complement is equals to A complement intersection B complement. A intersection B complement is equals to A complement union B complement. Okay. X is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What about the 1, 2, 3, 4, 5? And what about the B? 1, 2, 5, 6, 7. Okay. Now first we find out the A union B. Okay. This is the A union B. Now their intersection 1 to 5 is a सर्व आता A complement 6, 7, 8, 9, 10. The elements which are other than A but they are in U. B complement, these are the elements which are not in B but they are in U. Okay. Now first we prove A union B complement is equals to A complement intersection B complement. What about the A union B complement? A union B complement, that is equals to 8, 9, 10. Okay. A union B complement. A union 1, 2, 3, 4, 5, 6, 7. या व्यतिरिक्त एलिमेंट्स कोणते राहिले? The 8, 9, 10 की जे U मध्ये. Therefore A union B complement is 8, 9, 10. Next, A complement intersection B complement. We have A complement हा B complement. या दोघांचा intersection means what? The common element. They are the 8, 9, 10. 8, 9, 10. And hence A complement intersection B complement is 8, 9, 10. And therefore from 1 and 2 we have in bracket A union B, its a complement is equals to A complement intersection B complement. Hence De Morgan's law is proved. What about the next? A intersection bracket complete complement is equals to A complement union B complement. Again, first we find out the A union B. Okay. And the next their intersection 1 to 5. Next A complement, B complement. Okay. A intersection B complement. A intersection B complement means the elements other than 1 to 5 but they are in U. Okay. Then what are the elements? The elements are 3, 4, 6, 7, 8, 9, 10. 3, 4, 6, 7, 8, 9, 10. This is the A intersection B complement. What about the next? A complement union B complement. A complement union B complement. Both of them will collect it and the common element will take the one time. Okay. The elements are 3, 4. Okay. 3, 4, then 6, 7, 8, 9 and the 10. These two are equal 3 and 4 and hence A intersection B complement is equals to A complement union B complement. Okay. Now the question number 6. If P is equals to X is such that X square plus 14X plus 40 is equals to 0. This is the quadratic equation. Q is equals to X is such that X square minus 5X plus 6 is equals to 0. R is equals to X is such that X square plus 17X minus 60 is equals to 0. And there is universal set. What is that? Minus 20, minus 10, minus 4. Next 2, 3, 4. This is the universal set. Then find P union Q, Q intersection R, P union in bracket Q intersection R, P intersection in bracket Q union R. Now the first, if we solve this quadratic equation, then you will get the factors, that is a minus 10 and minus 4. This is the quadratic equation. Their factors are in first bracket x plus 10, in second bracket x plus 4. Then you will get minus 10 and minus 4. Similarly here, this is simple quadratic equation, x square minus 5x plus 3. In first bracket you will get x minus 2. In second bracket you will get x minus 3. The elements are 3 and 2. Next is x square plus 17x minus 60. Then what are the factors? Plus 20x plus 20. In second bracket x minus 3. Then you will get minus 20 and 3. These are the elements of the PQR. What about the x? Minus 20, minus 10, minus 4, 2, 3, 4. Okay. This is the universal set. Now, our question. P and this is the Q. Their union. Okay. Is there any common element? No. Therefore, we take the element P union Q is equals to minus 10, minus 4, 3, 2. Q, 3, 2, R, minus 23. And what about their intersection? Common element किती आहे? 3 आहे. Therefore, Q intersection R is 3. Next, P, minus 10, minus 4. Q, 3, 2, R, minus 23. Therefore, what about their intersection? Their intersection means what? The common element between the Q and R. 3 is a common element. Okay. Next, देअर विथ युनियन P, म्हणजे 3 चं कोणाशी युनियन करायचं या P शी युनियन करायचं. मीन्स यू विल गेट the elements -10, -4 and one more element, it is a 3, and hence P union in bracket Q intersection R. Q intersection R मधनं किती मिळाला आपल्याला? तर 3 मिळाला. आणि त्याचा युनियन कोणाशी करायचा? तर P शी करायचा. Then you will get -10, -4 and the 3. And the next. Okay. P intersection Q union R. Okay. Is there any common element between them? There is no common element between the P intersection in bracket Q union R, that is equals to 5. Now the question number 7. If A and B are the subsets of X and n of X is equals to 50, n of A is equals to 35, n of B is a 22, n of A complement intersection B complement is 3, then find n of A union B. What is the n of A union B? N of A union B is equals to n of X minus n of A union B complement. And this is the formula. Now substitute n of X is a 50. N of A complement intersection B, that is equals to 3. Therefore, n of A union B, which is the 47. Okay, A formulas आहेत मात्र. You have to remember all these formulas. Next is a n of A intersection B. तो find out करायचा आपल्याला. N of A intersection B is equals to n of A plus n of B minus n of A union B. हा युनियनचा तो फॉर्म्युला आहे. फक्त आपण हे टर्म लेफ्ट हँड साइडचं राईटला आणलं आणि हे राईट हँड साइडचं आपण लेफ्टला आणलं. ओके. अँड देअरफॉर n of A intersection B, n of A ची व्हॅल्यू, n of B and n of their union, these are the values, and then you will get n of A intersection B is equals to 10. Next, this is also important formula, that is n of A complement intersection B is nothing but n of B minus n of A intersection B. And suppose इथे B complement राहिला असता तर n of A minus n of A intersection B. Okay, substitute the value, that is a 22 minus 10, then you will get that is equals to 12. आता हे बघा इथे n of A union B complement, therefore n of A union B complement is equals to n of X minus n of A complement intersection B. Again substitute the value, n of X is 50, n of A complement intersection B is a 12, and hence n of A union B complement, and that is equals to 38. All these are the formulas that you have to remember it. Now the next question. Question number 8. In an examination, 40 students failed in physics, 14 chemistry, 35 in mathematics, 20 failed in maths and physics, 17 failed in physics and chemistry, 15 failed in mathematics and chemistry, and 5 in all the 3 subjects. Okay, 5 students असे होते की ते तिन्ही subjects मध्ये fail. If 350 students appeared for the examination, how many of them did not fail in any of 3 subjects? Okay. Now the first, the set of P is a set of students failed in physics, C is a set of students failed in chemistry, and M is a set of students failed in mathematics. Therefore, we have the number of the elements are the 350. N of P is a 40, N of C is a again 40, N of M is a 35. Their intersection, N of maths and physics 20, physics and chemistry 17, maths and chemistry 15, and the students who fail in all these 3 subjects are 5. Then the number of the students who failed in at least one subject. At least one subject means what? N of M union P union C. Means we will calculate here N of M plus N of P plus N of C plus N of M intersection P intersection C. Okay. And the next is a minus N of M intersection P minus N of P intersection C minus N of M intersection C. Substitute the value. N of M 35, N of P 40, N of C 40, and there all these 3 were 5. Maths and physics 20, physics and chemistry minus 17, maths and chemistry 15. Okay, if we simplify it, then you will get N of M union P union C means the number of the student who failed at least one subject is 68. Therefore, the number of the student who did not fail in any subject, म्हणजे 68 विद्यार्थी असे होते की ते कमीत कमी एका तरी विषयामध्ये फेल होते. Therefore, the number of the student who did not fail in any subject is 350. Total number of the student minus 68, and then you will get 282. And hence the number of the student who did not fail in any subject is 282. Okay. कोणा तुम्ही बघू शकता हे? Okay. Now the next problem. A company produces three kinds of products, A, B, and C. The company studied the preferences of 1,600 consumers and found that the product A was liked by 1,250, the product B was liked by 930, and the product C was liked by 1,000. The products A and B were liked by 650, the products B and C were liked by 610, and the products C and A were liked by 700 consumers. Okay, 30 consumers did not like any of these three products. Find the number of consumers who liked all the three products. Only two of these products. Okay, now see this. The given that the total 1,600 consumers were studied. Therefore, n of x is equals to 1,600. Let A be the set of all consumers who liked the product A, B is the set of all consumers who like the product B, and C is the set of all consumers who like the product C. Therefore, n of A is equals to 1,250, n of B is 930, n of C is 1,000, n of A intersection B is 650, n of B intersection C is 610, n of A intersection C is 700, and their complements. Okay, that is the n of A complement intersection B complement intersection C complement, means those who do not like any of one, means n of A complement intersection B intersection C complement, and that's equals to 30. Okay, now see this here. N of A union B union C is equals to n of x minus n of A union B union C complement. This is the formula. Okay, n of x. If we operate this complement sign, then this union will become intersection, and all this ABC will become their complement. And what are the numbers who that is not a single product, the number of the consumers are, they do not like the number of the consumers are, they are 30, and the total is 1,600. Okay, 1,600 minus 30, there then you will get 1,570. Okay, this is next. All the three products, those who like all the three products. Therefore, n of A, n of B, n of C, n of A intersection B, n of B intersection C, n of A intersection C, and n of A union B union C. Okay, then by using the formula, their union will apply here, union formula. N of A union B union C is equals to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Substitute all the values. Okay, then you will get, what is here, n of A intersection B intersection C, means these are the consumers who like all the three products. Okay, and if you simplify this, then you will get n of A intersection B intersection C is equals to 350. Now the next, therefore the number of the consumer who liked all the three products is 350. Now next, only two of these products. Okay, now here see this, n of A intersection B intersection complement C, म्हणजे दोन आवडतात आणि हा C तो नाही आवडणारा product, third product they do not like. Then what is the formula here? N of A intersection B minus n of A intersection B intersection C. What is the formula for here? आपण असा फॉर्म्युला बघितलेला आहे. N of A intersection B complement is equals to n of A minus n of A intersection B. Similarly here, n of A intersection B with intersection C complement is nothing but n of, this is the A, means what, this is the A. And what is the remaining? This total is remaining. That is minus n of A intersection B intersection C. 650 minus 350. Then you will get the 300. Okay. म्हणजे दोन आवडणार आहेत यामध्ये, तिसरा नाही आवडत. Similarly here, n of A complement intersection B intersection C. Then you will get n of B intersection C minus n of A intersection B complement intersection n of A intersection B intersection C. This is the constant everywhere now, 350. But n of B intersection C is a 610 minus 350. Then you will get 260. And what about the next? आता इथे B नाही आवडणार आहे. That is the n of A intersection B complement intersection C. That is nothing but the n of C intersection A हा घेणार and minus n of A intersection B intersection C. It's a 350 common for all these three. Any of the two. म्हणजे काय की दोन AB आवडतोय पहिल्यांदा, दुसऱ्यांदा BC आणि तिसऱ्यांदा AC. And similarly, if we find out it, and therefore the total number in first case is 300, second is 260, and third is a 350. If we add it, then you will get 910. These are the number of the consumer who liked only two of these three products, and they are the 910. And therefore the number of the consumer who liked only two of three products are 910. Okay. And in this way, we have completed all the introductory part before the exercise 1.1. Okay. Now, in my next video, we will see the exercise 1.1. We'll see now the next video. Till then, goodbye.